Ever wondered why your code sometimes give you a garbage value, even when your logic seems perfect? Or why computers seem to speak a language that's entirely alien to how we think? Today, we are going under the hood to master the art of thinking in zeros and ones. Hi everyone, I am Supratim, your coach here at Techmine Guru. We are diving into bit manipulation basics. Human logic works in base 10, thinking in powers of 10 like 5 times 10 to the power 3. But machine logic is built on base 2. Computers don't see the number 5011. They see a stream of electrical states on and off. To be a great developer, you must bridge the gap between these two worlds. So let's compare them. Base 10, the number 5011 is broken down as 5 times 10 to the power 3 plus 0 times 10 to the power 2 plus 1 times 10 to the power 1 and plus 1 times 10 to the power 0, which gives us 5000 plus 10 plus 1, which is 5011, right? Similarly, in base 2, a number like 5 is simply 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0, which gives us 4 plus 0 plus 1, which is equal to 5. So how do we convert this? So to convert decimal to binary, we use the remainder method. And for converting binary to decimal, we will use sum of powers. So suppose if 20 is given in the base 10 and you have to convert it into binary, then you will keep on dividing 2 until you get the result 0, right? So 20 divided by 2 will give 10 and the remainder as 0. 10 divided by 2 will give remainder 0. 5 divided by 2 will give 2 as result and remainder as 1. 2 divided by 2 will give 1 as result and remainder as 0. And similarly, 1 divided by 2 will give you 0 and the remainder as 1. So in binary, we will represent it as 10100, right? Similarly, if a binary number is given, so to go from binary to decimal, we use the sum of powers. For example, 00001101 maps to this position. So first position will be 1, second will be 2, third will be 4. If you notice, it is like 2 to the power 0, 2 to the power 1, and like this, we keep on going. So how do we add all of this? So 0 into 128 plus 0 into 64 plus 0 into 32 plus 0 into 16. All this will give 0. That's why I have not mentioned here. Now 1 into 8 plus 1 into 4 plus 2 into 0 plus 1 into 1, which will give us decimal number as 13 on the base 10. Also, you can check for this number, which will give you the result as 160 on the base 10. So binary math is just stacking. And you just have to remember that 1 plus 1 will give you 0 as a result and carry as 1. So this is the binary representation of 27 and this is the binary representation of 11. And we know how to convert from decimal to binary. So 27 plus 11 will give you 38. And how do we calculate the same in binary? So 1 plus 1 will give 0 and 1 as the carry, right? This 1 plus 1 will again give 0, but 1 is there in the carry. So the answer will be 1 here. Now 0 plus 0 will give 0. 1 plus 1 will give 0 and the carry as 1, right? This 1 and the carry 1 will give answer as again 0 and the carry will be 1 and this carry will be forwarded. And if you convert this decimal again to binary, it will give again 38 only. So this is how binary addition works. Now let's understand about some bitwise operators. So there is AND operator, which is like a strict operator and which gives result if and only if both inputs are 1. Similarly, OR, also called optimistic operator, it will result 1 if any input is 1. Similarly, XOR, the difference detector, it's 1 if the bits are different and 0 if they are the same, right? This is essential for finding unique elements in array, which we will do in later classes. Lastly, the NOT operator, it is like just flipping the bits from 0 to 1 and 1 to 0. So let's apply these operators on some numbers. So this is the binary representation of 5 and this is the binary representation of 6. And on doing AND of both, what we will get? Since we know that 1 and 0 will give 0, 0 and 1 will give 0, 1 and 1 will give 1, and 0 and 0 will give 1. So 0, 1, 0, 0, which is the binary representation of decimal number 4. Similarly, if we have OR, if we are doing OR between 5 and 6, 1 and 0 will give 1, 1 or 0 or 1 will give 1, 1 or 1 will give 1, and 0 or 0 will give 0. So this is the binary representation of the decimal number 7. Similarly, if you want to see the power of XOR, then we know that if result is 1, only if bits are different. And if result is 0, that means the bits are same, right? So 0, 0, both are same bit, it will give 0. 0, 1, different bit, it will give 1. 1, 0, different bit, it will give 1. 1, 1, same bit, it will give 0. 1, 1, same bit, it will give 0. 1, 0, different bit, it will give 1. And 0, 1, different bit, it will give 1. So this is the binary representation of the decimal number 198. So this is called operator logic truth table. If 0 and 0 are there in A and B, then A and B will give 0. A or B will also give 0. And since they both are same numbers, the A's or B will also give 0. Similarly, if A is 0 and B is 1, A and B will give 0. A or B will give 1. And since they are both different numbers, A's or B will give 1. Similarly, we will get exact same thing for 1 and 0 also. A and B will give 0, A or B will give 1. And since they are different numbers, A's or B will give 1 only. Lastly, for 1 and 1, A and B will give 1. A or B will also give 1. But since they are the same number, A's or B will give 0, right? Now let's see by taking a bigger example. Let's have input A as 20, whose binary representation is this, and input B as 45, whose binary representation is this. So we just simply put these two things and try to do the AND. So 0, 1 will give 0, 0, 0 will give 0, 1 and 1 will give 1, 0 and 1 will give 0, 1 and 0 will give 0, and 0 and 1 will give 0. So this is the binary representation of number 4. Similarly, if we do the XOR, we will get 0 or 1 will give 1, 0 or 0 will give 0, 1 or 1 will give 1, and similarly, we will get the rest of the numbers. So this is the binary representation of the number 61. And now if we do the XOR of this, 0 and 1, both different numbers, it will give 1. 0 and 0, both same numbers, it will give 0. 1, 1, both same numbers, it will give 0. 0, 1, different numbers, it will give 1. 1, 0, different numbers, it will give 1. And 0, 1, different numbers, it will give 1. So this is the binary representation of 57. So you will see that how input A and input B on applying specific operators gives different results. So same input, but we are getting 3 outcomes. So this is how we do for the positive numbers. So how to do it for the negative numbers? In case of negative numbers, we consider this bit as the MSB, which is also called most significant bit. So this bit will only tell you that whether the number is positive or negative. So if it is 0, it will be positive, and if it is 1, it will be negative. So how to find the same? Suppose you have given the number 5, whose binary representation in 8-bit format is this. So there are 2 steps. First step, you have to take complement of what is the input, which is like negating all the bits, and then you have to add 1 into it. So after inverting all the bits, you will get the 1's complement, and after adding 1 into the 1's complement, you will get the 2's complement. So if you invert all the bits, 1 will become 0, 0 will become 1, 1 will again become 0, and rest all other zeros will become 1. And if you add 1 into it, it will be 1, 1, 1, 1, 1, 0, 1, 1, right? And since this number is telling us that this is -5, let's talk about 8-bit range number, 32-bit range number, and 64-bit range number. We have often heard that 32-bit integer it is. Also, we have heard 64-bit integer. Also, we say that its long is of 64-bit, 8 bytes, like that. So 8 bits means 1 byte. So what is the range? So the simple formula is of calculating any bit range will be minus of 2 to the power n minus 1 to 2 to the power n minus 1 minus 1. You simply keep the value 8 here and you will get the result. So it will be minus 2 to the power 7 to 2 to the power 7 minus 1. And 2 to the power 7 is 128. So minus 128 to 127. Similarly, if you keep 32 here, you will get this much big range. And if you keep 64 here, you will get this range. So why we need to understand this? Suppose you have given 2 integer A as 10 to the power 5 and integer B as 10 to the power 6, right? And you are told that you have to multiply both the integers and you have to keep the result in integer C, right? So the expected result will be 10 to the power 11. So 10 to the power 11 is much bigger than the max int ranges. So it will give some garbage value. So what may be happening under the hood? So whenever we are compiling the code, our code converts into assembly language first, and then it converts to machine code. So in the assembly, what may be happening is that if you are multiplying a and b, then mul of a and b will store the result into a temporary variable, which will be like 32-bit register. Why? Because a and b are integers, so we have one 32-bit integer bucket only, and then we simply copy the temp variable to C. So for this, the solution is doing the typecasting. So when we are calculating it, the calculation happens in this int first, and then the result is stored in long, right? So we just need to promote A to long from int, so that the bucket size increases and it has the 64-bit bucket now, right? So if we have the 64-bit bucket now, when we are applying this typecasting long, then this temp variable will not be 32-bit register anymore. It will become 64-bit register. And since C is already long, so it will simply copy the temp to C and nothing will overflow. So let's think of one more problem. So imagine you have given an array where the constants are the length of the array will be 10 to the power 5, and every element can be up to 10 to the power 6. So if you do sum of all the elements of the array, you will get 10 to the power 11, right? Because if you have 10 to the power 6 range numbers, like till 10 to the power 5, then what is the maximal possible sums? It will be multiply of both, right? So it will give you 10 to the power 11. So at that time, we have to calculate the answer in long only. Otherwise, our garbage value will be coming. So today you learn to speak the language, thinking in binary, that is zeros and ones. Now you know how to manipulate bits using AND, OR, XOR, and NOT operator. And you know how to handle negative numbers by using the help of MSB and 2's complement. And now you also know how to prevent overflows during calculation by using larger bucket typecasting number. So in the next lecture, we are going to learn about string basics. If you found this deep dive helpful, hit that subscribe button for Techmine Guru. With this, myself Supratim signing off for today. Till then, keep coding, keep optimizing, and keep learning.